Hi everyone and welcome at another episode of the Global AI Notes. Just as every week we have a guest speaker and today we'll have Niels Rogge who will talk about an introduction to open source AI models on Hugging Face. So let's have a look. Hey Niels and welcome at the
Hi.
Global AI Notes show.
Hi, how are you?
I'm doing well. How are you?
I'm fine, thanks for having me.
Well, we're glad to have you on board today. Can you introduce yourself a little bit? Who are you? What do you do in your day-to-day work, and so on?
Sure. In my day-to-day work, I work as a machine learning engineer, actually at two different companies. So I'm working as a machine learning engineer at Hugging Face, where I mainly do open source contributions. And then I also work part-time at ML6, which is a Belgian AI consultancy company, which implements AI use cases for businesses end to end.
Okay, cool. How did you start at working for Hugging Face?
It started through contributions that I did on GitHub. So this was back in 2020 during the COVID period that I saw like a cool model coming out from Google on Twitter, and I thought, yeah, why not try to implement this model and add it to the Hugging Face Transformers library, which is this quite known library for using state-of-the-art transformer models. Because for me, it was also like a way to better understand their software. And so then I started opening a pull request to add this model to the library, and then I started doing more and more contributions until I ended up working for them.
Yeah, that's cool. Well, it shows again that by trying things and helping actually other people by contributing to the open source, you learn a lot yourself, but it also brings opportunity for your future careers.
Yeah, indeed, it was like a win-win.
Nice, nice. So, Niels, what exactly do you want to talk today? What exactly do you want to talk about today?
Today, I would like to talk about two things. So, first, a bit about what is Hugging Face, the entire ecosystem, because Hugging Face has built like a lot of tools lately. So, I even had to update my slide to make sure everything fit in. And then I also want to talk a bit about why open source AI is good and why we need it, and why closed source AI may not be ideal.
Okay, cool. Well, I'm looking forward to it. If you share your screen with us, then I'll show it to the public. For the people who are watching live, if you're watching on YouTube, Facebook, LinkedIn, or Twitter, or let's say X, you can use the chat functionality. And if there's questions, don't hesitate to throw them in the chat, and then I'll ask them to Niels during the session or afterwards. So, Niels, the platform is yours.
Thanks a lot. Can you already see my screen right now?
Your screen is still the one from the streaming, so you need to share your. Yes, that's it.
Okay, okay. Nice. So you can see it even if I put it on full screen.
Yes, we see
All
it.
right.
Let's go. Go.
Awesome. All right. So thanks a lot for the introduction. So today I will talk a bit about Hugging Face. First of all, what is Hugging Face? I guess some people may already know it a bit. Then I'll talk a bit about the entire ecosystem, all the different tools that Hugging Face has already built for the community. And I will end by explaining a bit why open source may be needed to improve AI systems in the future as well. So to start off, what is Hugging Face? Well, Hugging Face is actually a startup. It's not really a startup anymore because currently we're already with 150 people. It's based in Paris and New York City. They initially started in 2016 by building a chatbot app, a bit like you have the ChatGPT web interface right now. So they started with this in 2016. It was also like an AI chatbot that you could talk to as like a friend. But then, they switched a bit in terms of their business model because Google open sourced their BERT model, which is a very popular natural language processing model. And then, yeah, the Hugging Face Transformers library was born, which is an open source library that you can use to get started with state of the art machine learning models. So then their mission became like trying to democratize good machine learning through both open source and open science. For example, also by reproducing models from papers which were not open sourced before. And so the focus is also on good machine learning. So there's also an important aspect on like the ethics side of things. So these are some headlines from the past. This was like, yeah, 2017 when Hugging Face launched their app for the AI friends when they were still in the chatbots business. And then, yeah, Hugging Face started switching to open source. So then they raised some money through several investment rounds. Lately, yeah, there was a Series D investment round, which gives us now a valuation of $4.5 billion. But our mission still remains the same, which is democratizing good machine learning. And so, yeah, as I said, I had already to update my slide here on like the entire ecosystem that exists nowadays around all the tools that Hugging Face has built. So I'm going to briefly go over like the most important ones. There are actually too many to describe in detail, and also it would probably become a bit boring. But yeah, here you can have like a bird's eye view over all the things that Hugging Face has built, and I try to group them a bit. For example, on the bottom left, you have the open source libraries that enable you to get started easily with machine learning models. So of course, there's the Transformers library, which is the most popular one, which started with the BERT model from Google. That was the very first one. Lately, Hugging Face, I think last year, started building also the Diffusers library, which allows you to play around with these models like Stable Diffusion, which is an open source variant of the DALI model from OpenAI. We also have a newer library now called Hugging Face Candle, which provides a Rust implementation. So Rust is a very fast programming language, much faster than Python. And so this is like a new library that we provide. For example, if you want to run a Whisper model in Rust, there's also now the transformers.js library, which allows you to run these things directly in the web browser in JavaScript. So that's a bit on the model side. Then on the training related side, we have libraries like TRL, PEFT, and Accelerate. These help you with training models. Then we have the datasets library, because of course you cannot train a model without any data. So the datasets library is really there to trying to make this as easy as possible. On the inference side of things, when you want to deploy models to production, we do provide some solutions, which I also will talk a bit in the next slides. And then on the front end side, like if you want to, for example, showcase a machine learning model to the world, you can create a Gradio demo, for example, or a Streamlit demo for that and host it on Hugging Face Spaces, which is really meant for machine learning demos. And so, the central place in all of this is the hub, the Hugging Face Hub website, which basically connects all of the pieces that I explained in the previous slide. So it's just accessible through huggingface.com. This is just the place where I can find all these models. So as you can see, there are now nearly 600,000 individual trained models on the Hugging Face Hub website. You can sort them, like for example, by downloads. You can sort them by likes. Nowadays, they are sorted by default on trending. So, for example, the Falcon 180 billion parameter model is now, of course, one of the most trending models. But every week there's a new one coming out. You can find the data sets here. You can find spaces, which are these machine learning demos. So here, for example, you can find some machine learning demos of the week. Like if you want to play around with this Falcon 180 billion model, you can do this here. So yeah, the Hugging Face Hub website is really the place where everything comes together. It's a bit like GitHub, but then more aimed towards machine learning, because yeah, you want to host quite a large files, which is not the case on GitHub, where you are just storing code, which are just Python scripts. Of course, with models like Falcon 180 billion, you need gigabytes of files to store, and so for that, the Hugging Face Hub is the ideal place to do that. And so yeah, you also have like this nice personal feed where you can find, for example, um, yeah, likes by people. For example, if someone has liked your model or your data set, or you can find like the trending spaces and so on. So yeah, a bit more in detail on all of these libraries that Hugging Face has built. So the Transforms library is, of course, the most known one. So it provides access to all of these state-of-the-art AI models in just a few lines of code. And they are spread across all of these modalities. So it's not just language. It started with the natural language processing models, but nowadays, we also support audio models like Whisper, for example, for speech transcription, but also computer vision models like, for example, the Vision Transformer model, as well as multi-model applications where you have models that, for example, take both images and text as an input and need to produce text as an output, for example. And then we also support now also time series models, also based on the transformer architecture. And so here you can see some simple examples. So here I'm illustrating the pipeline API, which allows you to do inference with AI models in just 3 lines of code. So for example, you can load a text classification pipeline, provide a certain sentence. Like in this case, we want to do sentiment analysis, whether it's positive or negative, gives you back an answer. You can just provide like any model from the Hugging Face Hub, and it will then run inference with that model. Same here with a multi-model model. So this one is using the Blip model from Salesforce, which is a very nice image captioning model. So you can provide it with an image and it will generate a text describing that image for you, as shown here for these 2 parrots. And so it's mainly for PyTorch users. So PyTorch is currently like the go-to library for neural networks. We also do support other frameworks like JAX and TensorFlow, but most of our usage is in PyTorch. And the same holds for the Diffusers library, which is the other library that Hugging Face has built for models like Stable Diffusion, for example. So now we also support, for example, the new Stable Diffusion XL model from Stability AI. And so as you can see, in just a few lines of code, you can have like an open source variant of Midjourney, which has like almost the same quality as they showed in their paper. Like here we're generating a photo of an astronaut riding a horse on Mars. Yeah, as there are like many machine learning tasks, it can become confusing. So there's like this very nice page that Murphy created at Hugging Face, which lists like all of the individual tasks over the different domains like computer vision, natural language processing, audio, and now multimodal as well. And so you can just click on a certain task like depth estimation. You can find more information on what the task does, how to run it in code with the Transforms library. You can find linked models on the Hugging Face Hub, so you can directly go, for example, to this model, and so on. So I recommend the Hugging Face task page, to get an overview of all these different subtasks that exist within AI. And then the transformers and the diffusers library are very useful for machine learning models, but we of course also need some data to train these models on. That's where the datasets library comes in. You can view it a bit as a pandas library, but aimed towards machine learning engineers. So it's basically built on TensorFlow datasets, and it provides access to a lot of these datasets just using a few lines of code. So you can just go to the Hugging Face Hub, find a certain dataset like this one, which provides some awesome chat GPT prompts. And then you can just use the load dataset function here to load it from the hub directly into your memory. And actually, it also supports larger than memory datasets through things like streaming. So you can, for example, still process the huge Lion 5 billion dataset with Hugging Face datasets by just streaming in the data at the moment you need it without having to load the entire dataset into your memory at once. So yeah, these are some very nice features. I personally also use a lot from the datasets library. And it also has some nice utilities like caching the data automatically without reloading, as well as doing batched processing. So it's as easy as doing batched equals to true with a certain function on your dataset. Things like multiprocessing. So yeah, it's a nice library if you want to process your data for a machine learning model, and it's using Apache Arrow in the backend. And we also have this nice dataset viewer now on the hub, which allows you to like directly inspect examples from the data in the browser. So for example, here for the fashion imnist dataset, you can directly view these images and their corresponding labels. And now we also recently added a feature, for example, for text datasets, you can then also search the text directly in the browser, which is really nice. And then, so for these training-related libraries, I would say currently we have 3 of them called Hugging Face Accelerate, TRL, and PEFT. The Accelerate library is a nice library if you want to make your PyTorch training a lot easier. Like you don't need to handle all of the device placements. For example, if you want to move your code from a single GPU to a multi-GPU environment, as you can see here in this code snippet, it's only a few lines of code. You need to import this accelerator object. You can provide your PyTorch model, your training data loaders, and so on to it, and it will automatically place it on the right device, making sure that everything is done in the same way for both single and distributed training. And then the only thing you also need to add is like this accelerator.backward line, and it will basically take care of the training for you. And so it's aimed towards people that still want to write their own PyTorch training, but just don't want to handle this boring device placement stuff and so on. And it's also Accelerate is also very useful if you want to serve very large models by offloading the data to the available memory onto your system. So also for that, Accelerate is very useful. The TRL library is a more recent library by Hugging Face, also fully open source on GitHub, as all of our other libraries. And this one is mainly aimed at, so RL stands for reinforcement learning. So it's really aimed for people that want to do this RLHF, reinforcement learning from human feedback, on top of large language models like Falcon 180 billion model. As well as SFT, which is supervised fine-tuning. Oh, this is actually a typo. It should be SFT. And so, yeah, this is probably the secret sauce of ChatGPT. And so if you want to do this fully open source, the TRL library provides some very nice trainers for that. And then another more recent library is called PEFT, or Parameter Efficient Fine-Tuning. So yeah, typically when people started fine-tuning a transformer-based model, what they did was they just fine-tuned the whole model altogether. So we typically add like a head on top of the base transformer model, and then we train the whole thing end-to-end. But of course, that consumes a lot of memory. And especially with these larger language models, it just becomes not possible anymore to fine-tune this on consumer hardware. And so that's where the PEFT library comes in, because they do provide a lot of these parameter-efficient fine-tuning methods, like LoRa, which is a method by Microsoft that allows you to, basically only train a couple of linear adapter layers on top of your model, and you just keep your base model frozen. You only are fine-tuning these adapter layers on top, and these allow you to fine-tune huge models even on consumer hardware. So you can apply this to both transformer-based models, but also on models like Stable Diffusion. So on the internet, people are sharing a lot of LoRa's for stable diffusion. Then on the inference side of things, so once you've trained a model on some data, of course, you also want to deploy it and make it available in production. So for that, Hugging Face has built a solution called Inference endpoints. It's a very nice solution that allows you to just take a model identifier from the Hugging Face Hub website, and you can then spin up an endpoint for it. You can decide like what hardware it needs to run. You can decide, for example, whether it needs to be a CPU or a GPU or several GPUs. You can choose your cloud provider. So you need to choose between Google, Amazon, or Microsoft. And then Hugging Face will basically spin up an endpoint for you, allowing you to easily deploy a machine learning model for production use cases. And it also has nice things like scaling down to 0. So what this means is that if you don't have any requests, for example, then yeah, it will just not run. Like there are no costs being incurred at that moment. And then another inference solution is called TGI, which stands for Text Generation Inference. This is also fully open source, available on GitHub, to basically have like a backend for your large language models in production. So it has like a lot of nice utilities, like token streaming. So TGI is actually used as the backend for Chat UI, which is this web interface that allows people to basically build a open variant of the ChatGPT website. And so, yeah, Chat UI is using this TGI backend. And so both the front end and the back end are fully open source, allowing people to build this for their own use cases. And then, so I've talked a bit about like all the different tools that Hugging Face provides to do open source AI. You might be wondering why Hugging Face is really going for open source and open science, why we are not disclosing things like OpenAI, despite their name is not really doing. Well, there are a couple of reasons why we have this mission. And I think that they are actually nicely summarized by Mark Zuckerberg in a recent podcast on the Lex Friedman podcast, where he explains to Lex why they decided to open source the Llama large language models, which are currently one of the best open source large language models. And so, as he said, like he was playing around with the Llama model, and he said, okay, this is a really powerful tool like ChatGPT, Llama, and so on. They are very powerful tools, but also, let's be honest, they are very far from being a super intelligence. Despite some people claiming that they can do human-like reasoning and so on, especially us machine learning engineers at Hugging Face, we are very aware that these tools are very limited. Like we really know how limited they are, and so by releasing these things to the public, he says, yeah, you can basically improve it. You have more researchers working on it, so they can look into it. They can try to make them more efficient, which is already the case by libraries like ggml, which tries to implement these models in C++ to make them faster. There are newer methods like QLoRa, which stands for quantized LoRa, which is another more efficient way to fine-tune these models. There are other very nice open source works like flash attention, which enable you to run these models a lot faster. OpenAI is probably also using flash attention to train their models. You can have like architectural improvements. Like currently, we're still using the transformer architecture, which was introduced in 2017. But yeah, we're 5-6 years later, so it's maybe time for like a new improved architecture that fixes some of the issues with transformers, like for example the limited sequence length of these models. Another reason that Zuckerberg gives is open source tends to be more secure because more people are looking into them, finding holes in them, and eventually it also improves their products because as they gain more feedback from the open source community on these llama models, eventually the research also ends up in their products, like Facebook itself, for example. And And another reason why open source may be needed is that we just don't want to have like a few parties that are controlling like these things. I assume we don't want to have just a few companies like OpenAI, Anthropic, Cohere, and so on to really know what's going on behind the scenes for these large language models, for example. So it's very important that we make this as broadly accessible as possible so that people can research them and improve them. Decentralize them basically. There's also this nice tweet from Jan LeCun which nicely summarizes this idea. Jan LeCun is also very much in favor of open sourcing things. Actually, for me personally, the main reason why open source is needed is just because we need more progress. GPT-4, for example, is a very nice model. It's a very nice tool, but also it's very limited because it's only trained on text. It's only been trained to predict the next token with a fancy reinforcement learning step at the end. But scaling these GPT models will only get us so far. Like we will need some new radical breakthroughs. We will need some newer algorithms, some newer approaches, some newer paradigms. Like, for example, Ian LeCun is also saying that these models are very shallow in terms of their understanding of the world. Like, it's not like humans that they have picked up things, that they have touched things, that they know how things smell and so on. Like, they have just been trained on text, which is a very shallow knowledge of the world. So they really lack what they call a world model, like really knowing how the world works. We need some newer paradigms, like for example, self-supervised learning, which actually GPT-4 is already doing during its pre-training by predicting the next tokens. But as you can see, like if you give it a very simple question, like if it takes 10 hours to dry 5 clothes, how long would it take for 20 clothes to dry in the sun? Then, as of June 18 of this year, GPT-4 could not solve this question, which seems like so common sense for us humans. And so this is, because it lacks a world model, it doesn't really know how the world works. This is another example showcasing the limitations of the models that we have right now. If you ask them very simple questions, they still are very easy to trick. So that's why open source is really needed. The transformer itself was also released open source. So without the transformer being released, we would not have this powerful model. Also, Yoshua Bengio, who is another very famous person in the AI world, is saying that things like human-like reasoning, planning are lacking. They are not there yet. Also, things like out of distribution generalization. So these are also it's not that clear yet, like how well transformers can generalize compared to humans, for example. So there's still a lot of work to be done. And so if you're like me and you're on Twitter checking out the new research that's coming out every day, it's really amazing to see what open source can do. So every day there are new papers coming out on Arxiv where they improve certain methods, like for example, a smaller large language model that can basically outperform much larger models, or making it possible to fine-tune these models on limited hardware and things like that. I've talked about these things here before. The C++, the Llama C++ repository on GitHub is a very nice example for AI at the edge. So if you want to run these models on mobile devices, for example, without these open source libraries, it would maybe not be possible. There was also this very interesting memo that got leaked from an employee at Google that said, we have no moat, we have no competitive advantage, where he was going over all of these things that were coming out in the open source community, that they were basically not sure anymore whether they really have like a competitive advantage, because as you can see, you can also now run large language models on the phone and so on. So yeah, it's really nice to see this competition between closed and open source, and yeah, all the progress that is being made in the open source world. And yeah, I also wanted to briefly explain like why open source is also amazing in terms of what it can eventually help doing. So, for example, here, so as I said in the beginning of this presentation, in 2020, I started contributing my first model to the Transformers library. This model was called Tapas, which was a transformer-based model, very similar to the BERT algorithm from Google that you could apply on like an Excel sheet. So you can basically just ask a question to this model related to some tabular data, and then the model would be able to like select the appropriate cells from that table, which I thought was a really cool approach. And so then I started porting this model to the Transformers library. And yeah, to my surprise, like there was a whole new release around this model, which was very nice to see. And yeah, some people I really look up to, like Thomas Wolf, who was the creator of the Transformers library, one of the co-founders of Hugging Face, stated on Twitter that he was impressed by my contribution. So that was something I did not expect to happen. And now, if you look into like how this tapas model is being used, both in the industry and in research, it ended up being used in at least 20 different research papers, including from Google AI, which was really cool to see. And another thing I found really cool was that after the tapas paper, in 2022, there was another paper called Chart QA, which introduced like a new benchmark to do question answering over charts. They then introduced a newer model over this tapas model, which they called Vision Tapas, which then improved their performance on their benchmark. And then after that, there was another paper coming out from Google called Pix to Struct, where they compared themselves against this Vision Tapas model, and they again improved the performance. And then finally, in 2023, OpenAI released their GPT-4 model, and if you look into their blog post, they are benchmarking against this Pix2Struct model, which was a previous model in this pipeline. So it's really nice to see that. As you can see, they're also benchmarking here on these benchmarks like ChartQA. So yeah, by just doing this tiny contribution to the Transformers library, you end up having papers that try to improve upon them, release another model, and so on. So it's really like a cascade of research, eventually making progress on, in this case, question answering on charts and then tabular data. So yeah, that's just one illustration of why open source may be needed. And so yeah, I didn't stop, of course, at just contributing the single model. I contributed nowadays, I think, at least 40 different models to the Transformers library because, yeah, I just really like to do it. It's just really nice to see the whole world using these models. So they are used both in the industry and research. You can see like download numbers for the models on the Hugging Face Hub website. So, for example, the Layout LM version 3 model from Microsoft, which is a document AI model, which you can apply on your invoices, for example, ends up being used everywhere. So it's really nice to see the impact that it's having. So yeah, that's why I still keep contributing to open source to basically make it easier for people to get started with these models. And so, yeah, to help others starting to do open source contributions, I started a YouTube tutorial series on this recently. So if you're interested, you can find it on my YouTube channel. And I also created a Transformers tutorials GitHub repository where I basically add notebooks for all of these open source models that I add, and I make then fine-tuning tutorials for people such that they can easily get started with them. And a final note is a comparison of open versus closed source. So why would you choose an open source solution for AI? Well, there are some advantages and there are some disadvantages, just like there is with closed source. So the main advantages is that you're not sending any private data to another party. So yeah, everything is kept private. So that's definitely an advantage of using an open source model. You directly have access to the model, so you can also have insights into how the model is being trained, what data went in. You can start fine tuning it, and then you can eventually also deploy it or run it, for example, at the edge using a library like ggml. There are some disadvantages, like out of the box, these models, they will probably not perform very good on your domain, so there's probably some fine tuning needed. And yeah, you are responsible for the deploying costs yourself, so there will definitely be a bit of a learning curve if you want to deploy an open source model yourself, but it could be like a nice investment in the long term. And then why would you choose a closed source solution? Again, there are some advantages, some disadvantages. The advantage is that they handle everything for you. You're just paying for an API. So, for example, the OpenAI API just charges you for the amount of tokens that you send through it. Also, in terms of performance, yeah, nowadays these models are still on top of the leaderboards. But of course, there are some disadvantages as well, which is that, yeah, one thing that annoyed people I saw on Twitter, for example, and Hacker News, is that it's unclear like what training data goes in. So it's also unclear like how they are changing or updating the model. So it could be that your prompts and your model were working really fine in March, but then 2 months later, yeah, the performance of your prompts is not the same anymore. So yeah, you don't really have insights into how the model is being updated, what training data went in, and so on. So yeah, you don't really have control over that. There's also like this dependency on another party. So yeah, if you want to avoid like a login on a certain party, then closed source may not be the right solution for you. You're also sending some sensitive data over to another server, which is something you may not want, because yeah, sometimes they use the data that you send through it to improve their models and so on. And there's also this cutoff on the training data. For example, for ChatGPT, it's September 2021, so the model doesn't really know anything after that, unless you plug it with a browser tool, for example. So yeah, this was about it. So thanks all for watching it, and yeah, feel free to connect with me. I also created this very cool QR code with a Hugging Face space. So this one is using a control net to basically alter the style of a QR code based on a certain prompt that you give, and the QR code is still working.
Cool. Thank you very much, Niels. Quite an interesting introduction to the open source AI world. I personally learned quite some things also. Well, I have missed, well, although we are a bit over time, I will still want to ask maybe two questions. Um, you were showing the deployment of a model straight into an endpoint that's
Mhm.
in the Hugging Face environment. So if you go to the Hugging Face website,
Yeah,
you'll be able to have that option.
indeed. So the environment is managed by Hugging Face. So if you click here on deploy your first model, you basically need to provide a identifier here for a certain model on the hub. Could be, of course, your own trained model. Then you need to select on which cloud provider it needs to be
Mhm.
deployed. You need to provide like the hardware you want to use, and then yeah, it's as simple as creating this endpoint, and here you can find like the estimated cost.
Okay, pretty cool. It's a nice integration with the different cloud providers. Now, another question people might also have is we see a lot of things talking about responsible use of AI. Now, in the open source world, we have models that are also just available. How does Hugging Face also make sure that somehow these models are used in a good way?
Mhm. Well, one of the things we provide is a flagging option. So if you go to a certain model, um, so you can find all of these different models, and then there's basically this discussion tab. So there's, well, it's called community, and then here people can basically discuss the model and outputs that the model is giving, for example, and they can also flag it if you think the model is unsafe. Like, you can report it. You can specify, for example, if there are some ethical issues, some legal issues, whether it's spam and so on. You can give a reason for this. And another thing that Hugging Face is really focusing on is like um, reporting the CO2 emissions of the models that you train. So, for example, for the Bloom model, which is a large language model that Hugging Face trained, there's also a whole piece of information in the model cards where you can find more information on like the emissions that this model. So yeah, there's actually this tag for it. So if you click on this tag, you can see that about 80,000 models also report their CO2 emissions when training a model. So of course, yeah, we cannot really control what is happening with these models, but we try to be responsible. For example, if someone publishes a malicious model on the Hugging Face Hub, we make sure that it's taken into account and that yeah, some action is being taken.
Okay, cool. Thanks for also answering that question. Well, if people still have more questions, do reach out to Niels on his Twitter account or his LinkedIn account. But for now, that's it. We will see you next week with another episode of the Global AI Notes. Do follow us uh, on our LinkedIn account, the Global AI Community. Follow us on Twitter or on Facebook so you're up to date with the latest events. Nils, thank you very much for joining us today. I hope we will see more of you in the future. And for now, we say goodbye to everyone. Bye bye.
Thanks. Bye bye.